So we're gonna have a quick review on different volumes and surface areas. Might not be all the figures, but I'm just gonna go quickly over those figures that are most commonly used or asked about in these exams. So let's start with the volumes. So important figures that I would like for you to remember. There's gonna be the volume of the box, very common, okay? The box of or a cube. So you know that this is the figure that looks somehow like this, right? So a box or a cube, not necessarily a cube, but the definition of the volume with this will be the length, this will be the width, and this guy will be the height. So whenever we're having or we're given those three measures, you know that the volume of a box in general is the length times the W times the width times h, that is the height, okay? So the multiplication of these three measurements, the edges, the length, the width, and the height. Another very commonly asked figure as for volumes is the cylinder, okay? A right cylinder. That will eventually look something like this, okay? Well, let's do that a little better. Let's imagine that this is a well-drawn cylinder, okay? And in the cylinder, for us to be able to know the volume, it's important for us to know the radius of the base, okay? That you know, it will be the radius of the circle. And the distance from here to here, that is what we call the height, okay? So by having those values, you know that the volume will be equal to pi r squared times the height. All right, so we need to know the radius and we need to know the height here. These are the two most commonly used. There are a couple of other or few other figures that they tend not to be as common as the box or rectangular box or a cylinder, right cylinder, but every now and then we might see them. So one of those is the cone, that if we visualize it, the cone will have a circular base, and here is like a triangle, so your imagination, you know, is covering all the base. So this is kind of how the cone will look like. Here we need to know again what is the radius and the height. Remember the definition of the height: distance from the higher vertex perpendicular to the base. This will be the height. With those two values, we know that the volume will be equal to pi r squared times height, that's kind of a cylinder, but divided by 3. Okay, this will be the volume of a cone. So if you compare these things, check out these two equations. Basically, what we know is that in a cylinder, you can fit 3 cones. Basically, well, knowing that they both have the same radius, no? That's kind of what we're saying. Do remember this little equation is not, again, not the most commonly used, but every now and then it may appear in the exams. And the last figure that I want you to keep in mind as for the volumes is the sphere. So we have a circle here. Let's try to draw it a little three-dimensional, right? So it will be the sphere and the sphere. The sphere also has a radius, okay? So it's like a ball, but the ball also has a radius. So from the center of the sphere, the distance that goes to one point on the surface of the sphere, that will be the radius of the sphere, okay? If we know the radius of the sphere, that's everything that we need to know, because the volume of the sphere will be given by 4/3 times pi times the radius to the power of 3. That will be the volume of the sphere, all right? So it's a ball. Again, the radius in a sphere will be the point or the distance that goes from the very center of the sphere, a ball, to any point on the surface of the sphere. That will be the radius in this case, all right? So this as for volumes. Now let's talk about surface areas. There are two, again, common figures for which we could be asked the surface areas. That will be the cube and the cylinder, okay? So let's go with those two mainly. At any given moment, I remember once I was asked the surface area of a sphere, I will just give you the formula. It's not really a common question that we will be asked, okay? But if we talk about a cube, okay, then again, remember that the cube is a box where all the sides, all the faces are equal, right? So whenever we talk about the surface area, we can write down here the surface area is the area of the external faces, okay? Everything that goes to the outside, external faces. So in a cube, okay, this side might be x, but this side might be x as well, and the height it will be x as well, right? So if we talk about the surface area, let's call it like SA, surface area. What we do is, this is the area of one face, right? And this will be the area of another face, and this will be the area of their face. And what we have to do to find the surface area of a figure is to sum all the areas of the different faces. So if we do that in a cube, what we're doing is that the surface areas will be equal to 6 times the area of one face. And in this case, being a cube, the area of one face, the face is a square, so this will be 6 times x squared. With that little equation, you will find the surface area if the figure is a cube, all right? Now, what happens if you have a cylinder? So let's draw the cylinder here again. Let's see if I can draw it a little better than last time. I will write it down here, and again, my little base here, something like this. We know that here we have the height, right? That is the distance to the center, this will be the height, and the radius will be this distance, r. And if you can imagine, visualize a cylinder can be seen as this base, that is a circle, this other base, that is a circle, and it's kind of a rectangle that goes around the circles, right? That's kind of how you form a cylinder. If we see it like that, what we'll say is the surface area of a cylinder, in this case, will be equal to, again, the areas of these two circles. So I would say it's equal to 2 pi r squared, that's the two areas of the circle, plus the area of the cylinder, of the rectangle. The area of that rectangle, imagine why I'm going to write this, but that will be equal to 2 pi r times h, that will be the height of the cylinder. Okay, so you imagine the edge of the rectangle that will cover the circle as the base. No? This side will be equal to the circumference of the circle of the base, and this will be h. So that's why this, in general, will be the formula or the equation that we'll use if we want to find the surface area of a cylinder. All right, I hope that that's clear enough. These are the two most commonly asked. Again, I remember once, literally I only remember one exercise where I was asked something that had to do with the surface area of the sphere. But just for us to know, it also will also depend on the radius. Now remember that the radius of the sphere, let's imagine this thing, okay, that this is a ball. And the radius of the sphere, remember that is the distance from the very center of this to any point on the surface, okay? So this will be r. Whenever we know this value for the radius, we can say that the surface area of the sphere will be given by 4 times pi r to the power of 2. So do keep in mind those ones. The most commonly asked is the surface area of a cube. I have also seen several exercises where they might ask you to find the surface area of a cylinder. And I'll give you the surface area of a sphere because, well, I just remember that once I was given an exercise where this was important, but it's not the most common question. Still, if we know the concept, not a bad idea.